Okay, so here we have a system or a question about an oscillating system, and it's just like kind of a tricky problem, and we got to use some just some algebra, some smart algebra, and some smart trig to get through it. Okay, so we have this scenario where at time t equals 0, we have a displacement at of negative 8.5 centimeters. So at t equals 0, our position is right here. Okay. And the velocity is negative 0.92, which means we're moving that way. Okay. And the acceleration is pushing that way with a strength of 47 meters per second squared. And so we're asked to find omega phi in x sub m, or the amplitude. Okay, so a couple things we know right off the bat. We know that the amplitude is greater than 8.5 centimeters. We know that at time 0, our velocity is negative 0.92, and at time 0, acceleration is 47 meters per second squared. Okay, so the first step here is just going to start writing equations. So we can write functions for position, for velocity, and for acceleration. Okay, and we know that we don't know this, but we know the structure of these. Okay, when the velocity is negative v sub m sine omega t plus phi, we also know that it's negative x sub m times omega times sine omega t plus phi. And then we know acceleration is a of m, negative a of m, cosine omega t plus phi. And again, here we know that this is equal to negative x sub m omega squared cos omega t plus phi. Okay? And we're going to use this one, and this one, and this one to find these missing values. And now we're going to substitute in what we know about time zeros for each of these. So we know that at time 0, the position is negative 8.5 centimeters, and we're just going to use, so negative 8.5 centimeters is negative 0.085 meters, so say negative 0.085 meters equals x sub m times cosine of phi. And then we know from our velocity function, our velocity is going to be negative 0.92 at time 0, so negative 0.92 meters per second equals v sub m, or negative x sub m omega times sine of phi. And then finally, acceleration, 47 meters per second squared equals negative x sub m omega squared times cosine of phi. Okay, now right off the bat, we can actually solve for omega if we were to take this equation right here and this equation right here and divide them. Okay, so we'll go ahead and do that. Divide this equation by this equation. So on the left we get negative 0.085 meters over 47 meters per second squared equals x sub m cos phi over negative x sub m omega squared cos phi. And this is good because these cosines cancel out, x sub m cancels out, and we get negative 0.085 over 47 equals negative 1 over omega squared. So we can solve this, we'll multiply that up, multiply that over, divide that over, take the square root, and get that omega is equal to, so omega is equal to now 23.5 radians per second. Alright, the next thing that we can do now is use this to find phi. Okay, so we're going to divide two more equations. This time we're going to divide our velocity equation by our position equation, because if we divide sine over cosine, we get tangent. Okay, so negative 0.92 over negative 0.085 equals negative x of m omega sine phi over x of m cos phi. So these will cancel out. We know that omega is 23.5. Okay, and then we can divide those. And then also that sine over cosine is tangent. Alright, so we get 10.8 equals negative, putting omega 23.5 times tangent of phi. We're going to divide that over and find inverse tangent. So we do this and get that phi is equal to negative 0.43 radians. Okay, and what that represents is this. So let's say that this is a typical cosine function starting right here. If we've shifted it by negative 0.43 radians, then maybe we're starting from this position right here, just before where we normally would. Okay, so the last thing to do now is to find the amplitude, and so all we're going to do now is put in 0.43 right here, so that negative 0.085 meters equals x of m times cosine of negative 0.43 radians. Okay, and so we'll just divide negative 0.085 by the cosine of negative 0.43. In doing this, we get that the amplitude x of m is equal to about 0.094 meters, or about 9.4 centimeters. Okay, so after all this, we can now write our equation. So x of t equals 0.094 meters times cosine of 23.5 t minus 0.43. Okay, and there is our equation. And then just one last note, using your knowledge of trig, you can shift this by a cycle if you want and add 2 pi to it. Okay, and get the same result.